Right, so welcome back. Continue with our set of presentation for CIS 260. Today's set of topics is going to cover sequence and state diagrams and also time permitting activity diagrams. And the focus here is that we've spent some time talking about business objects diagrams, then class diagrams, relationships that we can include in our class diagrams. And the fact about the class diagram is that the class diagram is a static representation of software. For instance, if I have, let me see, if I have in mind an application, and that application involves some sort of a time schedule, So, for instance, I would like to have an application that manages like a work schedule of jobs, right? So that time schedule can be an object over here, and part of my time schedule, of course, would be a collection of time slots, right? Time slot. So time slot basically represents an item in the schedule. So of course the connection here goes that we have one-to-many relationship between the schedule and a collection of time slots. And in the same time, the time slots can be of various types, which would demonstrate another type of relationship to us, which would be a regular work day or weekday type of time slot, right? It could also be a weekend. So we would like to distinguish various types of time slots because they would represent different, different dynamics in the system eventually, right? And it could also be a sick day. So someone could place a sick day on that time slot. So it could be a sick day type of time slot that we might want to deal with. And also perhaps something like a holiday, which could have a special pay or other types of parameters. So naturally, because these four represent different types of time slots, I'm thinking about using inheritance to represent in the system that there could be multiple kinds of these time slots, right? So that would be the version of the diagram that I would like to use on my whiteboard, right? And so this essentially represents my world so far and what I'm trying to build on. So eventually today we're going to explore some dynamics of this, but right now just to make this a diagram that we can be using in our discussion, right? So this is what we typically refer to as a class diagram, right? So we can say that this is let me just write it up. This is time management system class diagram, right? So this is a class diagram. So class diagram represents existing classes, which simply drawn as boxes. As you learn more details about your functional specification and use cases, naturally these boxes will include also information about basically the information about data attributes and also a set of methods that represent behaviors. However, the class diagram does not represent any dynamics. It doesn't tell us, in what order objects are created, who creates these objects specifically, right? It doesn't specify when the object go out of existence, how soon. Is it possible to add and remove time slots dynamically? Or is the work schedule or time schedule populated with some pre-configured set of time slots which have to be used later on by the rest of the system? So anything regarding dynamics within the system is not, simply class diagram is not capable of showing it. It just basically, its idea is that you get the structure to look at. Ideally, this structure will exist at runtime, but how's it put together, it's basically unknown, right? The class diagram does not tell you that story.